Hello everyone. In this video, you will be learning the remaining part of yesterday's lesson which we were learning, which is about congruence and transformation. Now, half of the lesson about transformation we have already learned in yesterday's video. This is just for a quick review. What is transformation? It's the change in the position, shape or size of a figure. A transform is to change, right? So the four types of transformation we learned yesterday was translation, reflection, rotation, and dilation. So these are the four kinds of transformation we have to learn. And also in yesterday's video, I have completely in detail explained about this table, what is to be done, what are the tricks you need to remember when you are doing these following these transforming rules. So all that is detailedly explained in yesterday's video. If you have not watched that, please click the I card above and go back to that video and then watch that and then come back to watch this video, as you won't understand in this video as what to this table is about and about the rules of uh, transformation. So another thing you need to remember is the original figure, that's the question. The figure given in the question is called the pre-image, and the one which we are drawing newly or the resulting image of after applying the transformation is called as the image. Now here in this today's video, we will be learning how to determine whether the polygon with the given vertices are congruent. Now to make it easy, congruent means equal or same. So is it of the same shape, size? If this is what we are going to learn. So they'll be giving you two. They will give you the image. They will give you the pre-image. Pre-image means the figure which is before the transformation. So always the coordinates which they give the first is the coordinates of the pre-image. And then the coordinates which they give is the coordinates of the image after the transformation. So the first one is before the transformation. The second one is after the transformation. So using these coordinates, we have to determine whether the polygon with the given vertices are congruent or not. So let's see whether if it is congruent or not. All what we need to do is first start drawing the pre-image. First graph the pre-image. So to graph that, you will have to um, plot the points. So that's 1 is A, 4 1 is B, 4 3 is C. So when you join, you will get a triangle like this. Now this is the pre-image. Now the one we are going to draw is the image. So for image, we have PQR, that's negative 4 2, which is P, negative 1 2, which is Q, and R is negative 1 4. So this ABC is the pre-image and PQR is the image. Now, looking at both of that, you need to determine whether the polygon is congruent. Are they both equal? Yes, they are. How do you know that they both are equal? If you have drawn it accurately, once you look at them, they will look equal. But here they look one big and one small. The reason for that is that I cannot align these lines properly. As you know, I'm doing it through the graphs. So like graphically I'm trying to do through the keyboard, which I cannot. So it needs to perfectly, if you're drawing it with hand, it needs to be perfect. So once you join, you will get both of them looking equal. Okay. Now, as if you want to confirm, take any 2 points. So for example, take A to B. A to B is 3 units. You can count 1, 2, 3. Similarly, you will count on the other image the same corresponding units. So from P to Q, A to B means from P to Q. So it's 3, it's the same. Or take B to C. B to C, it's 2. Then Q to R, it's 2, which means both the triangles are congruent. Now, we need to say, first of all, it's congruent. So we say that triangles are congruent because triangle ABC can be mapped. Mapped means copied to triangle PQR by a. Now, it depends on what kind of transformation is here. Definitely, this part will change for every question. For every question, this part will change as you need to mention the transformation. What kind of transformation is it? Here you can say it's a translation because it's just slide. Just it has moved from one place to another. It has not changed the shape. It has not changed its anything. It has just been moved. So the movement is called as translation. So for this question, it has been the translation word has been used. Now you cannot stop there. Definitely you need to say what is the scale factor or what kind of translation is done. So to find that what is the scale or what is the unit for translation, you need to count from one point of the pre-image to the image. So from the coordinates, A is from the pre-image, and from the image the corresponding point is P. So A is corresponding to P, which means you need to count from A to P how many units have we moved. So from A to P, we have moved 5 units to the left and 1 unit up. Now, if you remember, in yesterday's video, we learned the rules of transformation in the translation in detail. If it was minus, it is going to the left. It was plus, it is going to the right. Similarly, if it was plus y, it is moving up. If it was minus y, it's moving down. We learned this all in detail. That's why I told you go to yesterday's video and watch that. Okay, so here you can see from A to reach to P, we need to move 5 units to the left and 1 unit right. So what does that mean by 5 units to the left? To the left means it's minus. So you need to minus 5 from P, right? So that's x minus 5, and you're moving up 1. So moving up means plus 1. So y plus 1 and x minus 5. This is how you find out the scale factor, in fact. The rule for translation, this is how you need to find. Once you graph, count how many units you are moving to the left. If it's moving to the left means from x, you will minus. Why? Because it is corresponding to the x-axis. So whether you're moving left or to the right, it is all from the x-axis. Now you're moving up or down, it's depending on the y-axis. So you need to remember it at least like that so that it will become easier for you. Okay, so this is how you find out the rule for translation. Let's look on to now this one. Isometry is a transformation that preserves length, angle measure, and area. So isometry is simply another word for a rigid transformation. Now, what are these meaning? It means just to keep the same shape, that's to keep the same length and the area, just like how in the previous one we saw. There is nothing changed. It's the same shape, same size, and same area. So that's what they say. So that's another word for, you can say congruence is an easier word for isometry. So also rigid transformation is another word for isometry. Now, more important than that is this. You need to remember if you do translation or rotation or reflection, the pre-images will be congruent to their image, means they will be equal to their image. The 3 transformations, which is translation, reflection, rotation. If you apply any of these, the pre-image will be the same as the image, except for dilation. When you dilate a figure, which means you can make it bigger or make it smaller, the pre-image will not be as same as the image. This important part is only for dilation. As the other 3, the pre-image and image will be the same. Only for dilation, the pre-image will not be the same as the image. Okay, let's see one more example. Determine whether the polygon with the given vertices are congruent. So, which is the pre-image? Pre-image is ABC, and the image is going to be PQR. So let's draw ABC first. So ABC, this is the triangle I would get if I draw ABC. Now the next, this is the pre-image. Now for the image, I have PQR. So PQR. This is the triangle for PQR. Now as you can see, the size has not changed. The shape has not changed. You want to make sure, take any 2 corresponding units, like from here A to C. A to C. So which is the point corresponding to A? It's P. And the point corresponding to C is R. So check the distance between A and C and P and R. A and C, how many units? 1, 2, 3, 4. From P to R, 1, 2, 3, 4. So it's the same, right? It's congruent. Now, you know that it's congruent. They both are same. But what kind of transformation is applied to this figure? Is reflection applied? Of course not. Reflection is like a mirror. You won't see in the mirror anything like this. Is it a dilation? Of course not. How can it be a dilation if they both are the same? And also, just we studied that dilation will not give you the same figure. Now, is it, now we are finished with reflection, we are finished with um, dilation. So the remaining two are rotation and translation. Now, is it a translation? Translation will not turn the figure. It will just move it up or down. That's all. It won't turn the figure. So the only one which turns the figure is rotation. So obviously, this is rotation. So one thing you know, the transformation is rotation. Now, when it is rotation, you need to say, is it clockwise or counterclockwise? Clockwise is in the same direction in which the hands of a clock move, and counterclockwise is in the opposite direction in which the hands of a clock move. So ABC is the pre-image. To move it to PQR, is it clockwise or counterclockwise? Definitely it's not clockwise. Clockwise means it should go this way. This has gone in the opposite way, which means counterclockwise. Now you know it is rotation, it is counterclockwise. Now you need to decide is it between 90 degrees or 180. Remember, if it's 180, it is equal to a reflection. If you have applied 180-degree rotation, it will be same like a reflection. But here it is not 180, so definitely it's need to be a 90-degree rotation. So the first thing you need to write is the triangles are congruent because triangle ABC can be mapped to triangle PQR by a rotation. Now what kind of rotation? Rotation about 0, 0. That's from the origin. 90 degrees counterclockwise. Yes, it is a bit lengthy, it is a bit difficult, but by practice you will get to know what you need to do. So let's start practicing some questions. So these are the same questions from your book. You can refer to the question numbers. Okay. So first, determine again. They want you to know, tell whether these two um, figures are congruent. So to make it more easy, I will just write down these coordinates once again, right under each other, so that I know which are the corresponding points in each figure. So B, then C is 2 and 6, and D is 2 and 4. All right. So the corresponding points, let me write them down below. So this is for the pre-image. Okay, now for the image, we have W, which is negative 2 and 2, and X is going to be negative 2 and 3. Y is going to be 1 and 3, and Z is going to be 1 and 2. So now there are two things you can do. Either you graph and find out which is more easier, because this is what even in your practice workbook has been given, to graph and find out whether they are congruent or not. Else you can look at the coordinates. Look at the coordinates, they have something in similar. So you can find out the pattern, what has happened here, and then find out the transformation. Now first let's graph the ABCD. So ABCD is going to be negative 4 and 4. So negative 4 and 4 is here. This is A, this is B, right? And this is C, this is D. So join them. Okay, just join these points. So you will be left with a rectangle. So let's write the points. I forgot to write the points. This is A, B, C, and D. Okay, now this is the pre-image. Okay, now let's draw the image. It's negative 2 and 2 here, W. X is here, Y is here, 1 and 3, 1 and 2. So this is the image. As you can see, as soon as you draw, you can make it out that if it is congruent or not. Do they look congruent? Of course not. They don't look congruent. They are not the same size. Though the shape is same, but they are not the same size. So they are not congruent. So now you need to write the explanation in detail. How are you going to write it in detail? You need to write it by using the same details as I as I showed you before. So let me write that in detail. You need to say the triangle you can use a symbol triangle, but as I cannot draw now anything, I'm just writing the triangle ABC, ABC. Let me make it easy for you rather than writing all that explanation. So the triangle ABC and, oh, it's not a triangle first of all, it's a rectangle. Okay, so we can use the word figure. The figure ABCD and WXYZ are not congruent as they cannot be mapped. They can't or they cannot be mapped. Okay. But you need to describe the transformation which has taken place. So, as the transformation is dilation. It has dilated. The bigger one has become smaller. So you need to say dilation. Now, when you say dilation, you need to mention the key, means the factor, by how much has it dilated. So to find out how much it has dilated, we need to find out the difference between these coordinates. Now, rather than going to negatives, let's take the positive one. How did the 2 become 1? You have to either minus 1. 2 minus 1 will give you 1. But 6 minus 1 will not give you a 3. So both of them need to be the same. 2 divided by 2 gives you 1. 6 divided by 2 gives you 3. Even the same rule here. Negative 4 divided by 2 gives you negative 2. 4 divided by 2 gives you a 2. So you found out the rule now. The rule is divide by 2. Okay, let me write down the rule here. This is only to make you understand. Rule is divide by 2. What are you going to divide by 2? The value of x and the value of y you are going to divide by 2, right? That's what you did here. This is the value of x and this is the value of y. So x divided by 2 gave you 1, y divided by 2 gave you 3. Now, as in a scale factor, we cannot write the scale factor like this because yesterday we learned that the scale factor needs to be kx and ky. So if I write it like this, how can I say what number stands in place of k? So to show that I'm making this half. So it's going to be the same. You multiply half by 2, you're going to get the answer as 1. You multiply half by 6, you're going to get the answer as 2. In fact, it's the same, right? Half x means, what is that? Half multiply x. So half of negative 4 is negative 2. Half of 4 is 2. So in fact, it's the same. Only that we are changing the divide into a multiply because we need to write the value of k. Okay, so this is going to be dilation with what key factor? Key factor of, I need to use the pen there because I cannot. Half x and half y. So this is how you need to explain that the transformation is not congruent. The figure ABCD and WXY are not congruent as they can't be mapped. The transformation is dilation with a key factor of half x and half y. Okay, hopefully this is clear, but yes, I can understand it takes time. Fine. Let's move to question number 2. Now these are the coordinates. This is for AB and C. Let me write down for C. I always write it like this so that I know which are the corresponding coordinates. So TUV is 1 and 1. Let's plot the draw the pre-image first. So the pre-image is ABC, negative 2 and negative 2. So that's here. And then negative 4 and negative 1. It's here. Negative 4 and negative 1. Negative 1 and negative 1. So that's a triangle here. So First join them so that you will get a figure. So this is going to be A, B, C. This is A, this is B, and C. Now this is the pre-image. Let's draw the image now, TUV. So TUV is 2 here, and then 4 and 1 is here. 1 and 1 is here. Okay, let me join them. Now, if you are doing it with a pencil, do it properly and perfectly. As you can see, I'm just trying to do it perfectly, but as much as possible. Okay, now name the points. That's important, you name the points. So this is going to be T, U, and E. Okay, so these are the two triangles we have. Now by the look, yes, they do look similar. They do look congruent. How do you confirm it? Take the corresponding points, which you can count. We can count here from B to C. So which are the corresponding points for B? B is U, C is V. So if you're counting from B to C, how many units are there? 1, 2, 3. There are 3 units. Similarly, you will count how many units from U to V. So U to V, we have 3 also, which means the triangles are congruent. So you need to write triangles are congruent. Type that. Okay. The triangles ABC and TUV are congruent as they can be mapped. Now, mapped by, after by, you need to know which transformation. What kind of transformation is applied? Definitely not dilation because they are of the same size. So either it needs to be translation, reflection, or rotation. Can it be a translation? No, translation does not turn the pictures. It just moves it around. So not translation. So you rule out translation too. Let me make it clear for you. What are the 4 types of transformations we learned? We learned about dilation, and we learned about reflection, and we learned about rotation, and also about translation. Okay, now we have to choose from this 4. Which one are we going to choose? Let's rule out one by one. Is it dilation? Definitely not, because dilation means it will become small or big. Is it reflection? Reflection means it should be exactly on the opposite side. Like if it is reflected, it should be somewhere here, right? Now, if you put this in front of a mirror, definitely you will not get a picture on the other side. So not reflection. Is it translation? Translation means moving, just move it up or to the side. No, translation will not change the side of the figures. So not translation. So we are only left with rotation. Definitely this is a rotation. Now rotation, so we can write here mapped by rotation. You know, when it is rotation, you need to decide on the degrees and the degrees as well as the direction. Now, is it clockwise or counterclockwise? You need to say that too. So let's find out, is it clockwise or counterclockwise? This is going to be definitely a clockwise because ABC became TUV, so it is going to be a clockwise. But is it 90? Now remember, if it's only 90 degrees, it will just move to another coordinate. Okay, you know this is one coordinate, this is coordinate, this is a coordinate, this is a coordinate. These are 4 parts here. If it was 90, it will just move from here to here. Okay, but this has moved to the other side, which means it is a rotation of, you need to write about 0, 0, but of 180 degrees. It's not 90. 90 will only move it to another side, another coordinate. Okay, but this is not here also. It has moved to the other side, which means it's going to be a coordinate for 180. Okay, so let's move to another question. Now, this question doesn't say that, like the previous one, determine whether the polygons are congruent or not. This question says apply the transformation. So you need to be very careful when you read the question, as this says apply, and that says that you have to find determine whether they are congruent or not. Now, when they say apply, this is much easier than finding out whether they are congruent or not. Okay, all what you need to do is you have to apply the transformation, name the coordinates, that's to find the new coordinates of the image, and then identify the transformation. So you need to do three things. One is find the coordinates, the new coordinates, okay? And the second is draw the image, and finally you have to describe what kind of transformation has taken place. So the pre-image, these are the coordinates. Now, as you can see, xy. Now, this rule applies for dilation. It applies for dilation. So x plus 5, y minus 4, which means for every value of x, you need to plus 5, and every value of y, you need to minus 4. So let's find out the image coordinates. So the g of the pre-image was 4, which means this is x and this is y. So x plus 5, which means 4 plus 5, that's going to be 9. And y was minus 1, minus 1 minus 4 will give you minus 5. So the new coordinate for g is 9 minus 5. Similarly for h, we are gonna, this is h prime, plus 5 minus 4. So 7 plus 5 will give me a 12. And, oops, okay, 3 minus 4 will give me a minus 1. Close the parenthesis. Then I is going to be, these are the coordinates for the image. So 7 plus 5 will give me 12. Again, minus 1 minus 4 will give me a minus 5. So these are the new coordinates we have. Okay, so I have to get a bigger coordinate plane because there is 12. There are bigger, quite bigger numbers for us to plot. Okay, so let's start drawing the image first. So this, the pre-image, sorry. The pre-image coordinates are this. So let's draw that first. So there's going to be a triangle because it has 3 points. So it is 4 and negative 1. So 4, negative 1 is here. Then 7 and 3. So 7 and 3, this point. Then I have 7 and negative 1. So it's here. Now let me join all the 3 of them. Hopefully it will be clear enough. So this is you will definitely do it more faster than me, as if you're drawing on a graph paper, it's going to be more perfect. And okay, so this is GHI. I will write the points later. Let me first plot these points. This is G prime, H prime, I prime. So that's going to be 9, 5. So 9 and negative 5. Where is 9 and negative 5? It's here. Then H is going to be, this is for the image. It's going to be 12 and negative 1. So 12 and negative 1 is here. And 12 and negative 5. So 12 and negative 5 is here. Now, maybe by now you can guess what kind of transformation has taken place here, right? It's clear that it is you see how difficult it is to draw on the screen. Okay, I'm trying to make it perfect, but if it's not, you must have drawn it on your graph book and you can see from that. All right, so we are done with the triangles. So let's name them. This is going to be G. And it doesn't look good. Okay, so this is G. Yes, it does take time to draw. That too on the screen, it's worse. This is G and this is H. This is H and this is I. So similarly, I have here, this is the image, G, H, and I. So what kind of transformation? Now we finished doing two things. We have found the new coordinates, we have graphed the figure. Now the final one is you need to say what kind of transformation has taken place. So what kind of transformation is that? It's just that it has moved. So that means it is translation. But we need to find out translation by how many units. So to find out how many units, let me show you how do you find. Now you need to get any two corresponding coordinates. So let me take G and G prime. Okay, so to move from G to G prime, that's going to be like you need to count how many units. This is 1, 2, 3, 4. So I have come 4 units down. Okay, this is down. I have come 4 units down. And from here, I need to move to the right. So it's going to be 1, 2, 3, 4, 5 units. So I have moved 5 units to the right. 4 units down, 5 units right. So let me write down the rule. So let me write down the transformation. It is translation. How many units? It is going to the right. Okay, so I can write it as xy, and I have translated this into, here already it's given x plus 5 and y minus 4. So it's y minus 4 and x plus 5. So it's a translation of x plus 5, y minus 4. And you can simply take it from the question itself, but here I wanted you to really understand how do you find the translation rule. That's why I showed you how to count the number of units. Now it's plus 5 because it's going to the right. It's minus 4 because it's going down. From the y coordinate, it's going down, but in the x coordinate, it's going to the right. Okay, let's try one more question. Here we have xy, negative xy. So first let's write down the new coordinates of the image. So it's minus y, minus xy means this needs to become minus and this stays the same. So it will become minus 3 and 2 and q will become minus 6 and 2 and r will become minus 3 and 5. So we are almost done half of the question. We found the new coordinates. Now graphing the coordinates are more easier, right? So first let's draw the pre-image. That's 3 and 2 here, and 6 and 2 here, and 3 and 5. 3 and 5. It's here. So this is for the pre-image. For the image, I have negative 3 and 2. Negative 3 and 2 is negative 3 and 4. Negative 3 and 2 here. Negative 6 and 2 is here. Now ignore this blue one because I could not find a coordinate plane without this symbol. So that's why I just took this. The 3 and 5 is here. Negative 3 and 5. So it's negative 3. Okay, let's join them. So this I need to join. Go to here. These points and these points. Similarly, I need to draw so after you draw, once you draw, you can find out what kind of transformation has taken place, which transformation is shown here. Now, please, when you're drawing on the graph book, try to draw it perfectly. As you can see, these lines are not straight in mine. So you need to draw it perfectly. So first, let's name them. This is P, and this is Q, and this is R, and this is going to be P prime and R prime and Q. Okay. Now, what kind of transformation has taken place? This is simply not a rotation. The thing has not rotated, right? It is not a translation as it has not moved. It is not a dilation, definitely, because they both are of the same size, so they both are congruent. So this only one can be, this is a reflection. It's a reflection. But when you say reflection, you need to say which axis. Is it a reflection in the x-axis or is it a reflection in the y-axis? Now, if it is x, if PQR was reflected in the x-axis, where will the figure be? The figure will be in this quadrant, right? But this figure is in this quadrant, which means it shows that it has been reflected in this line, so which is reflection about y-axis across. I forgot to write here across. So it needs to be reflection across y-axis. It's as easy as this, but yes, definitely you will not get always easy ones. You will definitely get some challenging ones sometimes. Okay, let's try this last one. Now, if you think you can do it, please pause the video here, do it by yourself, and then you can check the answer. It's better that way. Okay, the transformation given us is 1.5x, 1.5y, which means from the rule itself, you can find out that it's going to be a dilation. Dilation in the sense it's going to be a bigger enlarged one because it's 1.5 multiplied by x. So these are the coordinates given. This is for the image. So let's find out for the, this is for the pre-image. So let's find it for the image. So 1.5x, which means 1.5 multiplied by negative 1. What's that going to give you? 1.5 multiplied by negative 1 is going to give you a negative 1.5. Similarly, again, the rule for y is same. 1.5 multiplied by 5. So 4 multiplied by 1.5 is going to give me 6. Then for m, it's going to be negative 4 multiplied by 1.5. So 1.5 multiplied by negative 4 will give me, of course, a negative 6. Okay, then 1.5 multiplied by 4 will give me a 6. For n, similarly, negative 4 multiplied by 1.5 will give me a negative 6. And 3 multiplied by 1.5 will give me a 4. All right, so we have the coordinates of the pre-image as well as the image. So first, draw the pre-image. So for pre-image, it's negative 1 and 4. So it's going to be here. And negative 4 and 4, that's going to be here. And negative 4 and 3. What kind of triangle is this? Okay. Then for the pre-image, it's going to be negative 1.5 and 6. So as you know, 1.5 is between 1 and 2. Negative 1 and negative 2. So 1.5 I take in between and I point it. Plot that point here. So this is 1.5 and 6. Negative 1.5 and 6. Similarly, negative 6 and 6. Negative 6 and 6 is here. Negative 6 and 4 is here. So now don't get confused. If you think you are confused, draw the lines before you move on to the next one. So first let me join these. It looks somewhat funny. Okay. So this is the pre-image, which is LMN, and this is the image, which is the new one we got. So as you can see, it is an enlargement, which means this triangle, which is LMN, has been enlarged 1.5 times to get this triangle, which is L prime, M prime, and N prime. So this is what kind of translation is this? What kind of transformation is this? It is an dilation with what key? With the scale factor. Key factor or scale factor? Scale factor is the same of 1.5 x and 1.5 y. So this is how you identify the kind of transformation which has taken place. Identifying the transformation is easy compared to the one which we did the first two, which is to identify, to determine whether they are congruent or not. So hopefully this lesson is clear. The only key to understand is do more practice. Keep doing practice till we meet again.